Good afternoon, our dear listeners, and welcome to today's class. Today, we have come again this afternoon to discuss with you a topic in mathematics that is rarely brought and discussed with students. Perhaps on the grounds that the topic is not a popular one amongst the topic in what a mathematics. However, over the years, in some occasions, the topic has proven to be a savior to students sitting for different examination bodies that involve mathematics. So on that ground or on that note, we have come this afternoon and we have called up a topic to discuss with you in a way and manner that the students are going to benefit in two ways. Number one, to arrive at the correct answer of the question, and number two, to arrive at this correct answer faster than it is via other methods. And what topic are we talking about here in mathematics? What topic we are talking about is the Pascal triangle. The what? Pascal triangle. So I write it on the board, Pascal triangle. Pascal triangle. First of all, we ask ourselves, what is Pascal triangle? Because it begins by knowing what Pascal triangle is and then knowing how to arrive at the Pascal triangle. Pascal triangle, by the way of definition in algebra and mathematics, is the triangular arrangement of numbers, that give the coefficients of the expansion of any binomial expression written in the form of a plus b all raised to power n. So this is a binomial expression in nth power. So I repeat, the Pascal triangle in algebra in mathematics is the triangular arrangement of numbers that show the coefficients of the expansion of any binomial expression written in the form of a plus b raised to power n. So the first thing before us now is, how do we arrange numbers such that it can be called a Pascal triangle? We begin that with our students. First of all, we are going to establish on our board what we call rules, so that while we are arranging it now, it will become easier for us and it become clearer to our audience. So permit me to establish a columns or rules on this board. So let me have something like this. Let me call this row 1. Let me call this row 2. Let me call this row 3. Let me call this row 4. Let me call this row 5. And then down the line. In order to arrive at a Pascal triangle, we begin by writing what? 1 here. Just write 1 at that first row, which you have established. Then come down to the second row and write 1 in between this first one you wrote in the first row. How do I mean by this? You write 1 here and then you write 1 here, such that the one you wrote at the first row appears to be at the center of these 2 ones in this second row. The next step becomes, every row of a Pascal triangle begins with 1. Here, this is a row, it began with 1. Here is a row, it began with what? 1. So if I come down to this row, it must equally begin with what? 1. So here, I will begin with 1. But the moment I write this 1, I will now come up. I will say 1 plus 1 is what? 2. You now write what? 2. You have added this to this, so there is nothing to add to anything again. Then you now bring down what? 1. It is also important to note that the row of any Pascal triangle equally ends with what? 1. So it begins with 1 and ends with what? 1. Then you now come down to this row, equally begins with what? With 1. Then you now say 1 plus 2 is what? 3. 2 plus 1 is what? 3. You have added this to this, so you bring down 1 here equally. You write 1 here. Then you now come back again to this row now. You equally begin with what? 1. At this point in time, you say 1 plus 3 is what? You write here 4. 3 plus 3, you write what? 6. 3 plus 1, you write what? 4. And then you bring down what? 1. Assuming I have another row, perhaps I have another row here, then you equally begin with what? 1. Then you now say 1 plus 4 is what? 5. 4 plus 6 is what? 10. 6 plus 4 is what? 10. 4 plus 1 is what? 5. Then you bring down what? 1. Arrangement of numbers in this format is what is called a Pascal triangle, or what is called the Pascal triangle. So if anybody says draw or give a Pascal triangle, this is what we call a Pascal triangle. And we call it a triangular arrangement because this appears in form of a triangle. You see, it appears in form of what? A triangle. It appears in form of what? A triangle. So the next thing is, how do we relate this Pascal triangle to a binomial expression? Then let us relate to that. So if I come, the first row which we have here is a time or a point where this n takes up a value of what? Of 0. So what we have here in this first row is a plus b all raised to power what? 0. That's what we have. Do remember that anything raised to power 0 in mathematics is what? Is 1. So meaning that this is equal to what? 1. Then we now come down to what? To row 2. How do we relate this row 2 now with this binomial expression? At this row 2 where we have 1 and what? 1. The value of this n is what? Is 1. So that what we have here becomes what? A plus what? B all raised to power what? 1. And of course, anything raised to power 1 in mathematics is itself. Therefore, what I have here is equals to what? A plus what? B. And you know that the coefficient of this A is what? Is 1. And the coefficient of this B is what? Is 1. That's the reason of this 1 and 1. Because you are saying that this Pascal triangle gives the coefficient of the expansion of any binomial expression written in this form. Here we had a plus b raised to power 0, which gave us 1, and that was why we had a 1 in the first row of the Pascal triangle. Then in the second row, we had a 1 and 1, and this 1 and 1, of course, stand for the coefficient of any binomial expansion. But we are saying that in this particular row 2, the value of this n is what? Is 1. Because the value of n started from 0, the next one is going to be 1. Of course, this one is going to be 2 when we are done with this. So in that case, n becomes what? 1, and we have 1 here. So what I have here is what? A plus b all raised to power what? 1. And of course, in mathematics, anything raised to power what? 1 is itself. So what we have here is what? A plus what? B. And of course, in mathematics, when a letter is written without anything written behind it in form of a coefficient, the coefficient is assumed to be what? To be 1. And that is the reason why we have 1 here. Equally, what I have here is what? Is b, so the coefficient is 1. So that is why I have 1 here. So when I come to what? To the row 3, of course, the value of my n becomes what? 2. And what I'm going to have here becomes what? A plus what? B all raised to power what? All raised to power 2. So how are we going to expand this? I am going to expand this the way you know. The way you had earlier been taught. Then we now relate whatever thing we are going to have as the answer with the numbers I have here in the third row of the Pascal triangle. Of course, you know that when you have a plus b raised to power 2 in mathematics, this is the same thing as what? A plus what? B. Close it. Open again. A plus what? B. This is what we call in mathematics a raised to power what? 3. A raised to power what? 2, sorry. And of course, when you have a plus b into a plus what? B, and you want to multiply out, you take the first what? Entry in the first what? Bracket to multiply all the entries in the second bracket. Then you return back and pick the second entry in the first bracket and then use it to multiply everything in the second bracket. What do I mean by this? This is the first entry in the first bracket. I'm going to use this A to multiply everything here. So A times A will give me what? A raised to power 2. The sign here is what? Plus. A times B will give me what? A what? B. I am done using this A to multiply everything here. So I will now come back here now to pick the second entry now to multiply everything. The second entry is what? Is B that begins with positive sign. So I will write plus. B times A is just like what? A what? B. The sign here is positive, the sign here is positive. Positive times positive is what? Positive. B times what? B is B raised to power what? 2. What do we do here? This becomes what? A raised to power what? 2 plus AB plus AB will give me what? 2A what? B plus what? B raised to power what? 2. And this becomes the answer of expansion of this. So how do we relate this answer which you have with this particular third row? The relationship there is the coefficient of A raised to power 2 here is 1. And look at how I have 1 here. The coefficient of AB here is what? 2. Look at the 2 here. And then the coefficient of B raised to power 2 is what? Is 1. Look at what? 1 here. So that's the reason why we say that this Pascal triangle, that they give the coefficient of the expansion of any binomial expression written in form of this. The essence of learning this is, what if we go into examination hall and someone is asking us now to expand what? A plus what? B, all raised to power what? 5. It is going to take a longer time for us to be able now to multiply this out. But you, knowing the principle of the Pascal triangle, you quickly apply it here and you arrive at the answer at a flash. So the next thing we are going to go over, you haven't known how we can relate a Pascal triangle to this binomial expression, is how do we write these letters? I want to show us something here so that we see how we can write these letters. So permit me to clean here. Permit me to clean here. I want us to see here. The letters involved here is A and what? And B. If you watch, the first letter here is what? A. The power of this A is what? Is 2, which of course is the power of what we have here in this binomial expression. When we came down to the second term, the power of A decreased by what? By 1. That's the reason why you're having ordinary A here, and then B came in here. So that if this power of A is what? 1, and power of B here is what? Is what? 2. When both of them are summed, we'll be able to have what we have here. And then when we come here now, the power of A automatically becomes 0, and everything goes over to what? Over to A. So without wasting time, let us see something now. If we are now told now to get now the power of what? To expand what? A plus B, open and close, all raised to power what? 3. No longer raised to power what? 2. What we are going to do quickly is to come back to this Pascal triangle. Here is our what? Our first row, which is 0. Second row, this is the first row, which is 0. N is 0 here, N is 1 here, N is 2 here, N is 3 here. So they are referring to this particular row of the Pascal triangle. And that particular row of the Pascal triangle is 1, 3, 3, and 1. So let us first of all write it this way. I have 1, I have what? 3, I have what? 3, and I have what? 1. The next thing I'm going to ask myself there is, the letters involved is what? A and B. Okay, so here becomes what? A raised to power what? 3, because we are discussing here. A raised to power what? 3 plus. When I come over here now, this A is going to reduce by 1. The power of A here is going to reduce by 1. So I'm going to have what? A raised to power 2, and then I will have what? B. It has reduced by 1. When I come over, I will now say plus. When I come over here now, my A equally will now reduce what? By 1. Then I will now have ordinary what? A B raised to power what? 2 plus. Then when I come here now, I will now have what? B raised to power what? 3. And this becomes your what? Your answer when they ask you now to expand this. Don't you see that looking at now the Pascal triangle, you can equally get expansion of any particular letter of in any particular binomial expression of what of interest. So permit me to equally clean this board, call up like 2 to 3 binomial expansion now. Let us now do it together as a form of what? Exercise, so that our students will now be able to follow up very much well. So permit me now to clean here. What if now we are told that we should evaluate A plus B all raised to power what? 4. When you are given this to expand in exam hall and you do not know the application of the Pascal triangle, neither do you know the application of binomial theorem, you are going to waste all your time here. So, but then the moment you know this, you can arrive at the answer of this thing quickly. Remember that we said that the value of what n here is what? 0. The value of n here is 1. The value of n here is 2. The value of n here is 3. And the value of n here is what? 4. And if you watch now, n is here and n is talking about 4. So the row of the Pascal triangle that we're interested in is in this. What are those letters there? The letters there is what? 1. Then the next one is what? 4. The next one is 6. The next one is 4. And the next one 4. I called up this number we have here. Put it here. We now come here. The first one is going to be a raised to power 4. So I have a raised to power what? 4. I'll say plus. In this case now, this a raised to power 4, the power 4 is now going to reduce by 1 to enable b to come inside here. So I'm now going to have what? A raised to power what? 3. B. I will say plus. The value of this power, a raised to power 3 is going to reduce by 1. So I'm going to have what? A raised to power 2, b raised to power 2 plus. Then I come here. The value of this power of a is also going to reduce. So I have what? A, b raised to power what? 3. And here I'll say plus, b raised to power what? 4. Do you see that this is your answer? And of course, when one multiplies anything, the answer is that thing. So this is just like writing a raised to power 4 plus 4, a raised to power 3, b, plus 6, a raised to power 2, b raised to power 2, plus 4, a, b raised to power what? 3, plus. When one multiplies this, you have what? B raised to power what? 4. This becomes what? The answer. So with this, arriving at the answer of whatever thing they ask us is very simple. This is, of course, what we call the application of binomial what? Principle or binomial what? The application of the Pascal principle or the Pascal triangle in expanding binomial expression. So anybody can ask you, or if you have a book down there, you can try it to now get the value of what? A plus what? B all raised to power 5, and then try A plus what? B all raised to power 6. With this, you don't have a problem, because you quickly arrive at what are the answer. Okay? So I don't want to believe that you have started having a problem because we are making effort to make sure that whatever thing we discuss with you are very quite transparent and then very much clear. So permit me now to clean this board and then call up some exam questions that we have drawn from different examination bodies that cut across JAM, WAEC, NECO, cut across even JUPEB, then cut across NAPTEB, and see how we can apply this particular binomial Pascal triangle in solving those problems. Thank you for your audience thus far. So permit me to clear here. So of course, you remember how to prepare the binomial triangle. Have 1, have 2. In fact, as we are solving that problem, we are going to prepare it again. The first question says, and I write, that's the first question. The first question says, number 1. Simplify A plus B raised to power 3 minus A minus what? B raised to power what? 3. Look at the question that we are just given to simplify. Simplify A plus B raised to power 3 minus A minus B raised to power what? 3. If you do not know the application of Pascal Triangle, you might find this in funny to arrive at the answer very fast. Especially when time is essence in the particular exam you are sitting for. So we are quickly going to call up the idea of Pascal Triangle, apply it here, and you see how we can arrive at the answer very quick. So as a way of solution, so permit me to divide this board this way. So I have here a solution. If this were a binomial, if this is what a binomial what expression, the value of n here is what is 3. So we first of all now give ourselves the Pascal triangle where we can arrive the value of n being what 3. Then remember that we had row 1, we had a row like this, we had a row like this, we had a row like this, we had a row like this. Here we had what? 1. Here we had 1 and 1. Here we had what? 1. 1 plus 1 is what? 2. Bring down what? 1. Here we had what? 1. 1 plus 2 is what? 3. 2 plus 1 is what? 3. Bring down what? 1. And then perhaps we have then the value of n here equals 0, n here equals 1, n here equals what? 2, and n here equals what? 3. So we can use this one. Meaning that we have prepared a Pascal triangle that will be able to help us to expand this. Because here, the value of n is what is 3. So with that, I'm going to come down here, and then the numbers under this row is given as what? 1. Here is what? 3. Here is what? 3. And here is what? Is 1. We are dealing with what? A. So A will take the power of what? Of 3 in the first term. So here I have what? A raised to power what? 3. In the second term, the power of A will reduce by 1. And that 1 that it is has reduced with, B will now come inside. So what I'm going to have here is what? A raised to power 2B plus. In the third term, the value of what? Of A is going now to reduce again by 1. So here it is now going to be what? A B raised to power what? 2 plus. Then here it is all going to be what? B, and we have B raised to power what? 3. And of course, this is the same thing as 1 multiply this will give me what? A raised to power 3 plus. Here is what? 3 A raised to power 2 B plus. Here is what? 3 A B raised to power 2 plus. Here is what? B raised to power what? 3. So that is the value we have there. Don't you see how we have used the Pascal triangle to expand this? Then we now quickly come over to here. We call that one up equally. So what we have there is what? We have this one, of course, is for the first one. So the second one is now going to be, we have here, we have what? 1, we have what? 3, we have what? 3, and then we have what? 1. Then we come here. A is going to take the entire power. So I have what? This is what? A raised to power 3 plus. We are going to be careful here. In this particular place, you see that here is what? 3 A raised to power 2. So I still have what? 3 A raised to power 2 must still be here. Here I am meant to write what? B. But our B here is what? Minus. So you are now going to use what? Minus. You now write minus what? B. You close it, say plus. Then you now come here, look at, you still have your A here, so you now have your what? Your A here. But B here is what? Minus. So you are going to write what? You are going to write minus what? B, all raised to power what? 2. Then the last one is what? B, and that B is minus. So you're now going to have what? So you have plus, minus what? B, all raised to power what? 3. And by so doing, 1 times A raised to power 3 will give you A raised to power 3. Then we should be careful here. Our carefulness here begins by, here is minus. When this minus multiply this positive, it becomes minus. So I have minus 3 A raised to power 2B. Then I come over here. Here is minus inside the bracket, and this is a square on top. So this minus squared will change to positive. And that positive will multiply this to return positive. So I have plus 3AB raised to power 2. Then here I have what? Minus. And here is an odd what number, not an even number. Okay? So if you say minus raised to power 3, it is still minus. So what I have there is what? Minus what? B raised to power 3. And we are told to subtract this from this. And the first value we got was this. And the second value is this. So we are going to say, therefore, the first value we had was what? A raised to power 3 plus what? 3a squared b plus what? Here what? 3 what? A b squared plus b raised to power 3. We say minus. Remember that once you say minus, you open a bracket and write all these things inside. So you open a bracket and write what? A raised to power 3 minus what? 3a squared here. 3a squared what? B. Then this one is what? Plus 3ab what? Squared minus b raised to power 3. You close the brackets. So of course what you are going to have is what? A raised to power 3 plus 3 what? A squared b plus 3a b raised to power 2 plus b raised to power 3. Here is minus a raised to power what? 3. Minus to minus plus 3a squared what? B minus to plus minus 3ab squared minus to minus plus b raised to power 3. Then you check. You have a raised to power here, a raised to power 3 minus a raised to power 7. This and this is gone. You have 3a squared b here, and you have plus 3a squared. So all of them will now give you what? 6a squared b. You have plus 3ab squared here. You have minus 3ab squared here. So this and this will go. And you have plus b squared here. You have, plus b raised to power 3. So you have plus 2b raised to power 3. And with this, you have arrived at this expansion. You see how we can solve problems like this without necessarily wasting a lot of time by expanding this thing into 3 places, after which you begin to expand this one into 3 places. It is actually going to waste all your time. Thank you for your attention thus far. Still remember that once you have a challenge or a question, you are free to call your questions up now on the comment section. Once we come across it, we come to your aid. Do not forget to subscribe to our YouTube channel. Okay, permit us now to clean here and call. The second question we are going to solve that place says, and I write, that is question number 2. Question number 2 says we should simplify 2 plus root what? 3 all raised to power 3 minus. I have 2 minus root what? 5 root what? 3 all raised to power what? 3. So if you are given this kind of problem in an exam, you begin to blink your eyes on how to go about it. But with Pascal Triangle, it won't waste you time. You arrive at the answer very quickly. Permit me to close up my curtain so that these rays of light coming inside will not make our class not to be very much invisible to you. Sorry for that little distraction. We are back. As you can see, it's a little bit, it's better now. So this is what we have as a number 2 question to solve. So permit me now to clean here. We solve this. As we are solving it again, we are making even the first one we solved to be more comprehended or comprehensible by our audience. Of course, without wasting time, we are still dealing with what? 3 and 3. So we are still going to pay attention to this rule of the Pascal Triangle. So we are still going to use 3, 1, 3, 3, and 1 of Pascal Triangle while we are solving that problem. So we now come, here we are. So ordinarily, if we are dealing with what? A plus B all raised to power what? 3. Ordinary. You still remember that it is going to be a raised to power 3 plus 3 a raised to power 2b plus 3a b raised to power 2 plus b raised to power 3. When we have this kind of a thing, it is expanded this. We just finished solving a problem that looked like that. So we are going to use this idea to deal with all of this. So we now say therefore, when we have what 2 plus root of what 3 all raised to power 3, it is going to be. Anywhere I see a, I am going to use what 2 because 2 is taking the position of this a here. So which means here is going to be 2 raised to power 3 plus. Here is my 3 here. My a of course is 2, so I have multiplied by 2 raised to power 2. Look at my b here, and my b is what is root 3. So I have what root what 3. The sign here is plus. What I have here is what 3. My a is here and my a is 2. So I have multiplied by what? By 2. Then my b is raised to power 2 and my b is root 3. So I have what? Root what? 3 all raised to power 2. The sign here is what? Plus. Then I come here. This is b and my b is root 3. So I have what? Root what? 3 all raised to power what? 3. That's what I have there. Okay, then I will return back. This is equals 2 raised to power 3 will give me 8 plus. 2 raised to power 2 is 4. 4 times 3 is what? 12. So I have 12 root what? 3 plus. 3 times 2 is what? 6. So I have what? 6 times. Now you should know that root 3 raised to power 2 is 3. That is root 3 times root 3 is 3. Root 3 times root 3 is what? 3. So I have what? 6 times what? 3 plus. Here is what we call, I have what we call the root 3 all raised to power 3. So this becomes 8. This is 8 plus. This is 12 root what? 3 plus. This time this will give us what? 18. This 18 plus we have root what? 3 all raised to power 3. 8 plus 18 will give us what? 20 what? Will give us 26. So this equals what? 20 what? 6 plus 12 root what? 3 plus root what? 3 all raised to power what? 2. We are done with this. We now come here and see. Therefore, we now call up this one. What we have here is what? 2 minus root what? 3 all raised to power what? 3. This equals. Here is my a, it still remains 2. So I still have what? 2 raised to power what? 3 plus. Here is my 3, so I have my 3. Here is my a raised to power 2, which is still talking about 2, multiplied by 2 raised to power what? 2. Then here is my b, and my b is minus root 3. Minus root 3. So you now have what we call minus what? Root 3. Minus root what? 3. Okay? So this is just like say multiply by minus root 3. Then you are here now. You say plus. Here is my 3. I'll write my 3. Here is my a. My a still remains my 2. Multiply by 2. Here is my b raised to power 2. And my b raised to power 2 is what? Is root 3. So I will now come here and write minus root what? 3 all raised to power what? 2. The sign here is what? Plus. The last one here is b raised to power 3. And my b raised to power 3 is what? Is minus root 3. So I have what? Minus what? Root what? 3 all raised to power 3. That's what I have there. Then I return back. So this will give me, this becomes what? 8. Then if you come here, of course, here you have 2 raised to power 2 is 4, times this is going to give you 12. So you have what? Let me claim here, you have plus what? 12. Here you have multiplied by minus root what? 3 plus. Here is 2 times 2, which is 6. This is minus root 3 raised to power 2. So, and then minus root 3 times minus root 3 will give us 3. Because this minus times minus will now cancel that minus. So what you have here becomes what? 6 times what? 3. Then you now come over here. This now becomes what? Plus. You have minus what? Root what? 3. All raised to power 3. Then you now come back here and you have that this be what? 8. Here is minus, here is plus. So you have minus. You have what? 12 root what? 3. Then plus. This time this will give us what? 6 times 3 will give us what? 18. Then here is going to be minus. Remember, okay, let me still have plus. We have minus what? Root what? 3. All raised to power 1 3. So with this, what we are going to do is this. 8 plus 18 will give us 26. So this is going to be 20 what? 6. Then this is minus what? 12 root what? 3. I want us to note something here. Very important. Even though we can decide to handle it that way, by coming now, well, we have already seen this one and seen it. In fact, let me for now handle it that way by saying plus minus what? Root what? 3. All raised to power what? 3. We are asked to remove this one from this one. So here is going to turn to minus, here is going to turn to positive, here is going to turn to minus. So please permit me to clean this part of the question. Permit me to clean here. So what we arrived at before is a 26 plus 12 root what? 3 plus root 3 all raised to power 3. We now have minus. Okay? We now open a bracket. So what I have here is what? 26 minus 12 root what? 3 plus minus root what? 3 all raised to power 3. Then we close up these brackets. So this will become 26 for this one plus 12 root what? 3 plus root what? 3 all raised to power 3. When this minus comes in here, you have minus 26. That minus will come here and change it to plus 12 root what? 3. That minus will come here and change this into what? Minus. You have minus root 3 all raised to power 3. And for that reason, this is 26, this is minus 20, this and this will go. This is plus and this is plus. So it is now going to be 24 root what? 3. Here is plus root 3 raised to power this. Here is what? Minus. Minus root 3 raised to power this. And the next thing you need to note is this. When you say minus root 3 raised to power 3, minus root 3, the other thing is going to be, it is going to change, this thing will still remain minus. When it comes outside here now, it turns to what? To be positive. So you are now going to say that this is going to be, what you are still having here is, you still have here to be what? Plus root what? 3 all raised to power what? 3. Here is minus. When this minus comes here, it is still going to be plus root what? 3 all raised to power 3. Because when this one comes out negative, it will not be that. So you now have what? 20 what? 4 root what? 3 plus what? 2 root 3 raised to power 3. You have something like this. You can cross-check to know whether we arrive at the answer correctly. But then, of course, the methodologies are quite clear to us. Thank you very much for your audience thus far. Our interest in just today's class is to bring the idea of Pascal Triangle to you and see how we can use it to solve the problem. Thank you very much.